Look up at the night sky on a clear autumn evening. Away from the orange haze of the city, nestled in the constellation of Andromeda, you will find a faint, elongated smudge of light. It is the most distant thing the human eye can see without assistance. To the casual observer, it is a ghost, a silent, static relic of the deep past. It looks peaceful. It looks like it is exactly where it belongs. But that stillness is a lie. That smudge is a trillion-star engine of gravity, a monster twice the size of our own galaxy, and it is currently engaged in an act of cosmic violence. For decades, the textbooks have told us that a collision is coming, that in 4 or 5 billion years, the Milky Way and Andromeda will smash together in a cataclysmic merger. They tell us it is a future problem, a distant apocalypse for a version of humanity that will likely no longer exist. They are wrong. The collision is not coming. The collision is here. As you stand there, photons from that distant spiral are striking your retina. But those photons aren't traveling through empty space to reach you. They are currently traversing a chaotic, turbulent medium where the outer reaches of the Andromeda Galaxy are already grinding against the outer reaches of our own. The two largest structures in the local group have already made contact. Their invisible atmospheres are mingling, their magnetic fields are intertwining, and the first stages of a multi-billion-year execution are already underway. We aren't just observers of a future crash. We are currently standing inside the wreckage. To understand how we missed this, we have to understand the profound, great blindness that defined our early understanding of the universe. Until the early 1920s, we didn't even know other galaxies existed. The prevailing wisdom, championed by astronomers like Harlow Shapley, was that the Milky Way was the entire universe. Everything we saw, every star, every nebula, every flicker of light, was just a small part of our own home. Andromeda was thought to be nothing more than a spiral nebula, a swirl of gas within our own borders, perhaps a solar system in the process of being born. But there was a whisper of the coming storm as early as 1912. Vesto Slipher, an astronomer working at the Lowell Observatory, began measuring the light coming from these spiral nebulae. He was looking for the Doppler effect. Just as a siren changes pitch as it moves toward or away from you, light changes color. Objects moving away are stretched out, their light shifting toward the red end of the spectrum. Objects moving toward us are compressed, their light shifting toward the blue. Slipher found that almost every nebula he looked at was redshifted. The universe was expanding. Everything was running away from us. Except for Andromeda. Andromeda was screaming toward us at 110 kilometers per second. It was a blue-shifted anomaly, a predator bucking the trend of cosmic expansion, hurtling directly down our throat. In 1923, Edwin Hubble used the massive 100-inch Hooker telescope to finally prove that Andromeda wasn't a cloud inside our galaxy, but an island universe of its own, millions of light-years away. This discovery expanded the universe a billionfold, but it also turned Slipher's Blueshift into a terrifying reality. We weren't just looking at a nearby cloud. We were looking at a massive, independent titan that had defied the expansion of the entire universe just to find us. For nearly a century after Hubble's discovery, the narrative remained the same. Andromeda is far away, it is moving fast, and it will hit us eventually. This was based on a fundamental misunderstanding of what a galaxy actually is. We used to think of galaxies like solid islands, distinct, bounded objects with clear edges. We looked at the glowing disks of stars and assumed that was the body of the galaxy. But the stars are just the visible bones. They represent barely 15% of the galaxy's total mass. The other 85% is a ghost. an ocean of dark matter that doesn't emit, absorb, or reflect light. The true body of a galaxy is this halo, a gargantuan, invisible sphere of dark matter and plasma known as the Circumgalactic Medium. This halo extends far beyond the reach of the stars, stretching over 1 million light-years in every direction. In 2020, using the Hubble Space Telescope's Project AMIGA, scientists mapped Andromeda's halo for the first time. They didn't do this by looking at the halo itself. It's far too faint to see. Instead, they used the light of 43 distant quasars, the incredibly bright cores of active galaxies billions of light-years away. As the light from these quasars passed through Andromeda's halo, the gas in the halo absorbed specific frequencies of that light. By analyzing that absorption, astronomers could see the invisible. What they found was staggering. Andromeda's halo isn't just a small envelope of gas. It is a massive, pressurized reservoir of plasma that extends up to 1.3 million light-years from the galaxy, and in some directions, up to 2 million light-years. Now, do the math. The distance between the Milky Way and Andromeda is roughly 2.5 million light-years. If Andromeda's halo extends 2 million light-years, and our own Milky Way has a similar halo extending outward, the conclusion is inescapable. The halos aren't just close. They are already overlapping. They are already pushing against each other. This changes everything. A collision in the cosmic sense isn't like two billiard balls hitting. It is a slow, gravitational drowning. The gas in our outer halo is currently colliding with the gas in Andromeda's. This interaction creates shock waves, compressing the gas and potentially triggering the birth of new stars. The very edges of our galaxy are already being altered by the proximity of the other. We are no longer two separate entities. We are a binary system in the first stages of a forced merger. But if the collision has already begun, why does the night sky look so peaceful? Why aren't we seeing the fireworks? This is where the physics of the temporal trap comes in. When you look at Andromeda tonight, you're seeing a ghost. Because the galaxy is 2.5 million light-years away, the light hitting your eyes right now left its source 2.5 million years ago. To put that in perspective, when those photons began their journey, our ancestors were Homo habilis. They were just beginning to use the first primitive stone tools. They hadn't mastered fire. They hadn't left Africa. We are looking at Andromeda as it existed 2.5 million years ago. In the time it took that light to reach us, Andromeda has moved closer by about 9 billion kilometers. The smudge in the sky is a lie. It's a delayed broadcast. We are reacting to a version of the universe that no longer exists. If a massive supernova were to rip through the heart of Andromeda right now, we wouldn't know about it for another 25,000 centuries. We are effectively blind to the present state of our own destruction. But the horror of the collision isn't just in its proximity, it's in its unpredictability. For years, we thought the crash was a mathematical certainty. In 2012, a major study using the Hubble Space Telescope measured Andromeda's tangential velocity, its sideways motion. Think of it like this. If you see a car driving toward you, it's easy to tell it's getting closer, but it's hard to tell if it's going to hit you head-on or just zoom past your shoulder. That sideways motion is the tangential velocity. The 2012 study concluded that Andromeda's sideways motion was so small that a head-on collision was inevitable. They predicted a direct hit in about 4 billion years. The internet was flooded with visualizations of the Milky Way being torn apart, its spiral arms shredded as it merged with Andromeda to form a new, giant elliptical galaxy dubbed Milkomeda. But in 2024 and 2025, new data began to emerge that threw this certain doom into chaos. This is the apocalypse when revision. It turns out that predicting the motion of two galaxies isn't a simple two-body problem. It's a chaotic gravitational brawl involving several other players. The first is the Triangulum Galaxy, or M33. It's the third largest member of our local group, and it's currently dancing around Andromeda. Its gravity tugs on Andromeda, acting like a cosmic sniper that could pull the galaxy off its collision course. Then there is the Large Magellanic Cloud, or LMC, a satellite galaxy currently falling into the Milky Way. The LMC is much more massive than we previously thought. It might be dragging a huge wake of dark matter behind it, which in turn pulls on the Milky Way, shifting our own position. A 2025 study titled Apocalypse When used the latest data from the Gaia satellite to run massive N-body simulations of the next 10 billion years. The results were a coin flip. The probability of a direct collision within the next 10 billion years has been revised down to just 50%. This doesn't mean we are safe. It means the nature of the collision is even more unsettling. Instead of a clean, predictable merger, we might be entering a long graze. The two galaxies might swing past each other, their halos shredding one another before they are pulled back for a second, third, or fourth pass. It's a slow-motion car crash that could take twice as long as the current age of the Earth to resolve. And yet, even if we avoid a direct hit for 10 billion years, the already here reality remains. Even a near miss at a galactic scale is a catastrophe. As the galaxies pass each other, tidal forces will stretch our spiral arms into long, thin tidal tails. Millions of stars will be flung out into the intergalactic void, destined to spend eternity in the dark, lonely space between galaxies. Our night sky would slowly empty out until only a few distant flickers remained. But what about us? What about the Earth? There is a profound irony in our quest to understand the Andromeda collision. We are obsessed with the fate of our galaxy, yet we are biologically locked out of the finale. The timeline of the galactic merger aligns with a much more local, much more certain apocalypse: the death of our sun. In about 1 billion years, long before the visible disks of the Milky Way and Andromeda make their first pass, the sun's luminosity will have increased by about 10%. This sounds minor, but it's enough to trigger a runaway greenhouse effect on Earth. The oceans will boil away. The atmosphere will be stripped. The Earth will become a scorched, sterile rock, similar to Venus. By the time the stars of Andromeda begin to fill our sky, making it brighter than a full moon, there will be no eyes left on Earth to see them. If any life remains in the solar system, it will have to be on the moons of Jupiter or Saturn, watching the sky from beneath miles of ice. If we could survive, however, the view would be the greatest show in the universe. As the galaxies merge, they won't actually hit each other in the way we think. The distance between stars is too vast. If the Sun were a ping-pong ball in New York, the nearest star, Proxima Centauri, would be another ping-pong ball in Atlanta. You could fire 2 swarms of bees at each other from those distances, and they would almost never collide. Instead of stellar impacts, we would see the collision of gas. Huge clouds of hydrogen and helium would slam into each other at hundreds of kilometers per second. This would trigger a starburst phase, a frantic, violent era of star formation. The sky would be filled with thousands of brilliant, blue, short-lived stars and the glowing pink nebulae of their nurseries. At the center of it all, the 2 supermassive black holes, ours, Sagittarius A star, and Andromeda's, which is significantly larger, would begin a terminal dance. They would sink toward the center of the new, combined galaxy, circling each other for millions of years. As they spiraled inward, they would release gravitational waves so powerful they would ripple the fabric of space-time across the entire observable universe. When they finally merged, the resulting kick could be enough to send the new, larger black hole hurtling through the center of the galaxy, or it could trigger a quasar phase, blasting jets of radiation that would sterilize large portions of the newly formed Milky Way. This is the ultimate fate of our home. We are currently living in the quiet before the storm, but the first raindrops are already hitting the windshield. The overlap of the halos is the signal that the isolation of the Milky Way is over. We are no longer an island universe. We are a component in a larger, more violent process. When you look at that smudge in the sky tonight, don't see it as a distant neighbor. See it as a reflection of our own future. See it as a giant that has already reached out and touched us. The light you see is 2.5 million years old, but the gravity, the invisible, inexorable pull, is happening right now. We often think of the universe as a vast, empty place where things happen on timescales so large they don't matter to us. But the Andromeda-Milky Way collision reminds us that the universe is a dynamic, interconnected web. We are moving. We are falling. We are colliding. The peaceful night sky is a masterpiece of perspective, a temporary illusion granted to us by the limits of our own perception. In the end, the Milky Way will vanish. Andromeda will vanish. They will be replaced by a giant, featureless elliptical galaxy, a retirement home for stars where no new suns are born and the gas has all been spent. It will be a massive, glowing tomb, a final monument to the two great spirals that once were. But that is billions of years away. For now, the collision remains invisible to the naked eye, hidden in the overlap of plasma and dark matter, a secret war being waged in the vacuum. We are the ghosts in the machine, living out our lives in the milliseconds between the first contact of the halos and the final merger of the cores. The smudge is still there, hanging in the constellation of Andromeda. It looks like it's waiting, but it's not waiting. It's already here. And as you look at it, remember, you aren't just looking at a galaxy. You're looking at the beginning of the end of everything we know. The cosmic clock isn't ticking toward a future event. The alarm has been ringing for millions of years. We just haven't been listening. As we continue to map the CGM and refine our models of the Triangulum and the Magellanic Clouds, the picture will only get more complex. We may find that the Milky Way has already been cannibalized in the past, or that Andromeda itself is a survivor of a previous merger. The history of the local group is a history of violence. We are just the latest chapter. So, the next time you find yourself under a dark sky, look up. Find that smudge. Realize that the space between you and that light is not empty. It is a bridge. It is a contact point. It is the site of a collision that has already begun to rewrite the story of our galaxy. The Milky Way is no longer alone. It is being embraced by a giant, and that embrace will not end until the two are one. The sky you see tonight is the last of its kind. Enjoy the view while it lasts, because in the grand scale of cosmic time, the lights of the Milky Way are already starting to flicker. The merger is underway, the halos are intertwined, and the island universe is a thing of the past. We are already part of something much bigger, much older, and much more terrifying than we ever dared to imagine.